DevOps is an approach that helps break silos between software developers and administrators. And it is one of those approaches that has made waves in the technological market and in software development lifecycle market. Great Learning brings you this session where we would be discussing CI/CD pipelines, an approach towards DevOps on top of AWS. So sit back and enjoy this session.
So we'll be talking about few CI/CD implementations using AWS developer tools. Okay, so I can assure you that this is not AWS developer tools on our one course, but we'll be talking about how AWS developer tools can be leveraged to create a powerful and scalable developer environment that can help you to get the code changes from source to the production faster than ever. Okay, so here is our agenda. So we will be having an overview of AWS CI/CD services, 3 use cases leveraging AWS CI/CD services, and the template files used in code build, code deploy, and code pipeline. That is basically serverless application deployment. And how do you debug your build or deployment failures if there are any, and how do you roll back your deployment? We will talk a bit about generic pipeline and how do you gauge your DevOps. And finally, we will have a quick demo on creating a code pipeline. Okay, so with this agenda, we'll move ahead. First, we will see an introduction to AWS CI/CD services. So at the end of this theory of talking about AWS CI/CD services, I'll open for questions. If you have any questions, we'll take it up, and then we'll move ahead with discussing about 3 workflows and the lab session. Okay. So first, the software release process. So all of your, from whatever the background you're coming from, either development, testing, DevOps, product management, whatever it is, you might have definitely heard and familiar with one software development methodology or the other, right? So whatsoever maybe the software development methodology we follow, the ultimate goal is to take your code changes from source to production, which ideally encompasses 4 phases: source, build, test, and deploy. Okay, let's see where does AWS CI/CD services fits in the entire software release phase. The first one, source phase, is where the complete code management happens, comprising checking in your source code, peer review, version control, and the AWS code commit is all around that. Okay. The second one, build phase, you will compile the code, you might run the unit test, and in case of container deployment, you might create the container images at the end of the build, and the AWS code build is designed for that. Next, what you see here is test. Here you will perform the integration test, UI load, stress test, or penetration test, whatever the kind of testing you have, and these integrations are with third-party tools. Sometimes, many times, the code build, AWS code build itself can be used to combine both build and test. And the third one is deploy. In deploy phase, the package generated in the build phase will be deployed to the target environment, be it your dev environment, QA, pre-production, or production environment. And from source to build and test, probably you might be installing it on your sandbox machine and testing. This entire process of repeating to validate your changes that gets into your source code is called continuous integration. And when we want to get the changes quickly to the production, that will be termed as continuous delivery. So here is the tools: software release phases versus AWS CI/CD services. AWS code commit is mapped to source. Code build is designed for building, and testing is by means of integrating with several third-party tools. The next one is code deploy. AWS code deploy is designed to facilitate deployment. And the AWS Code Pipeline is an end-to-end solution which comes handy to glue all these services. And Code Pipeline enables you to rapidly deliver features and updates with high quality through the automation of your build, test, and release process. So if you're wondering why am I using the term AWS CI/CD services instead of AWS developer tools, it's just because in this session we'll be talking more about AWS code commit, code build, code deploy, and code pipeline. These four key services which are designed for continuous integration and continuous delivery, but we'll not be talking much about CodeStar, Cloud9, and X-Ray, which altogether forms the AWS Developer Tools suite. Okay, so now let's have the bird's eye view of AWS CI/CD services. The first one to start with is AWS Code Commit. AWS Code Commit provides a fully managed source control service, and this is where your code is stored and managed securely. Most of the companies these days use Git for their source control management. So this code commit is powered by Git, and if you're familiar with Git already, well, you already know 90% of code commit. Okay, so the key feature of code commit though is it's backed by AWS technology. This means that your code can scale up and scale down based on their size, and there is no issue in that. So it's automatically handled all for you. So in code commit, both data in transit and data at rest are encrypted using AWS managed keys. Most importantly here, there is no size limit on the repos and also no restrictions on the number of repos that can be created in your AWS account. And you can have post commit hooks to call out SNS or Lambda function that can be configured in your code commit repository. So all that you do with any traditional source control management software like create a commit, view a commit, compare two commits, or create or delete a tag, initiating a pull request for code reviews are all very much possible in AWS Code Commit. And here are the key features, like the first one is visualizer. I really like the DAG-based commit visualizer to view the commits made to the repository. In this example, the screen print, whatever I pasted here, shows only the commits to a specific branch. Or probably I am having only one branch in this repository, that is why one line. But in case of you are having multiple branches, like you have your master branch, you have your feature branch or pre-production branch. So how the code flows between those 2 or 3 branches in your repository is all visually represented in this visualizer, and it is easy for you to see where what has gone wrong or whose commit would have caused the issue. It will be easier to narrow down with the visualizer. And we have a compare tool. You can check the changes between 2 commits or across branches. So the compare tool can be used to see the changes, and you can initiate the pull requests. Okay, and you can configure IAM policy to limit pushes or merges to a branch. Like you can have read-only user to a specific repo, and you can have a read-write user and users with admin permissions. So all that fine-grained permissions can be provided with IAM policies. Okay, so now that we have seen code commit and found a place to store our code, let's move on to the other logos in our workflow. The next one what we're going to talk about is AWS Code Build. AWS Code Build is a fully managed build service in the cloud that compiles your source code, runs your unit test, and produces artifacts that are ready to deploy. AWS Code Build eliminates the need to provision, manage, and scale your own build service. It scales automatically to meet peak build requests, and you pay only for the number of build minutes you consume. It basically provides pre-packaged build environments for most popular programming languages like .NET Core, Python, Ruby, Java, Golang, PHP, Node.js, all that. So the important thing to note here is you have the build environment for .NET Core, but not .NET Framework yet. That is the subtle thing you have to note. And the good thing here is you can also customize your own build environment by creating a Docker image, either uploading it to Amazon EC2 Container Registry or Docker Hub Registry. And the beauty here is you pay only by the time you use in terms of minutes for the compute resources you use. So even you have the code build project created, and if it is lying idle, you won't be charged. And it is default integrated with services like AWS Code Pipeline, or it can be integrated with Jenkins to trigger your build. In a nutshell, code build takes raw code, probably straight from the code commit or any other source control tool that you define. We will see what all it supports later. Run some tests and build options, and it creates a neatly wrapped deployment package for us. Okay. So the next one is AWS Code Deploy. AWS Code Deploy is a deployment service that automates code deployments to any instances, including Amazon EC2 instances or instances running on-premise or to the serverless Lambda functions. So it supports all these three. And AWS Code Deploy makes it easier for you to rapidly release new features. It helps you avoid downtime during deployment and handles the complexity of updating your applications. That's basically, once the automated deployment is configured and tested, the complexity of updating the applications is completely off your shoulders. It's only the initial time needed to configure it, test it, and keep it aside. So with the suitable deployment type, you can completely avoid downtime. So there are two different deployment types here: in place deployment and blue-green deployment. So by choosing what deployment strategy would work for the type of application that you're trying to deploy, you can completely avoid downtime and also configure to roll back automatically in case there is a failure. Okay. And you can deploy a nearly unlimited variety of application contents such as code, your serverless applications, Lambda functions, web and configuration files, executable packages, multimedia files or your video files, scripts, and so on. So AWS Code Deploy works with various systems for configuration management, source control, continuous integration, continuous delivery, and continuous deployment. So if we are really curious about what are the third-party tools that Code Deploy supports now, you have a page called product integration page it should be. So under Code Pipeline documentation, if you go and see there, you will have the pre-built integrations for popular third-party services that are already certified by the partners. So that will give you an idea what tools are supported. If what you're looking for is there, it's well and good. So why are we talking about this third-party service integrations? Basically is when you wanted to migrate from your data center to AWS, there is no hard and fast rule that you have to migrate all the services at one shot and move to AWS. That is next to impossible for everybody, right? We might want to do at our own pace. So having these third-party integrations facilitates that. That is, you can configure the Code Deploy project there by having it integrated with remaining things, certain things which already you have pre-built and running for years on your data center until you move or wanted to move everything there. So the choice is purely yours and the flexibility is available here. So next we'll see the components of AWS Code Deploy. So main components that we see is application, deployment group, revision instances, and the configuration files. Those are the main components, I would say. An application is basically a collection of software and configuration to be deployed to a group of instances. Typically, the instances in a group run the same software. For example, if you have a large distributed system, you might have web tier, app tier, database tier. So the web tier can be called as one deployment group where it will run the similar application on it. So that's what we would term as so the application that gets deployed to a specific deployment group is the same. And what is a revision here? A revision is a specific version of a deployable content, which could be a source code, post-build artifacts, web pages, your executables that you have created now, and the deployment scripts, along with the app spec file. That's a key thing here. We'll see what it is. The AWS Code Deploy agent can access a revision either from a GitHub or Amazon S3 bucket. So we saw code build, it will build the artifact and upload it to S3. If you upload it to S3 here, the revision will be pulled from S3 using AWS Code Deploy agent and install it. That's how it works. So there are two types of compute platform on which AWS Code Deploy deploys an application. That is either EC2 instance or on-premise instance. That is one. The second one is AWS Lambda. So what is a deployment group here? A deployment group is for grouping EC2 instances or AWS Lambda functions in code deploy deployment. In EC2 or on-premise deployment, a deployment group is a set of individual instances targeted for deployment. So here, deployment is an action of deploying new revision onto the instances. So we already saw the deployment type, I told, right? We have two types of deployment type. One is in-place deployment and blue-green deployment. For this purpose of all our discussions or the workflows that we're going to see today, we'll be using only in-place deployment. What is in-place deployment is you stop the services running on the existing instances, deploy application onto that instances, and then bring up the service. That is what in-place deployment. You're not going to have another all new set of instances where you will test the deployment, all that. So you're going to do it on the very same instances what you'll be using it. We'll see that later in the workflow now. What is an appspec.yaml file? It's a configuration file which specifies the files to be copied and the scripts to be executed as part of the deployment. And this deploy config plays a vital role here. It has a set of deployment rules that defines the deployment success and failure conditions used by AWS Code Deploy during the deployment. For example, if your application needs at least 50% of the instances in a deployment group to be up and serving the traffic, you can specify that in your deployment configuration so that a deployment does not cause a downtime. If there is no deployment configuration is associated with either the deployment or with the deployment group, then by default, AWS Code Deploy will deploy to one instance at a time. We will see how you configure this later. So basically, in AWS Code Deploy, application and revision talks about what to deploy, and this portion talks about where to deploy, and these configuration files mostly are into how to deploy. So these are the key things in a nutshell when you talk about code deploy components. And we'll move on to the last one and the most important one in this section, AWS Code Pipeline. So releasing software to the market at a fast pace is at the core of every business, right? So releasing feature changes or bug fixes to the production using traditional approach without any pipeline or something might be often error prone. So AWS Code Pipeline is a continuous delivery service you can use to model, visualize, and automate the steps that are required to release your software. With AWS Code Pipeline, you model the full release process from building your code, deploying it to pre-production environment, testing your application, and releasing it to the production. So you can configure the whole cycle in it. So AWS supports many third-party software solutions that you can plug and play into different stages in your development workflow. This can be especially helpful when you only need to use AWS tools for certain pieces of your workflow and wanted to reuse some of your existing implementations. Okay, so automating your build, test, and release process allows you to test each of your code changes or commits to catch the bugs or the issues while they are very small and easy to fix and very early in your development cycle. You don't have to wait for the D-Day or end of the day, find the issues and go ahead and fixing it. So you can assure production quality of your code because each changes goes through standardized release process. So there are two ways in which you can detect the changes in source code in the code pipeline. One is periodic checks to see whether there are any code changes using CloudWatch event, and then trigger the build so that your pipeline will run through. The other one, configure periodically. Either I want to run the build once in 2 hours, once in a day, like that. Doing so once in a few hours or several hours might sometimes be an advantage or disadvantage. So if you configure to automatically do the periodic check on the source changes and trigger automatically, the issues for every commit can be got very early and fixed it. Right? So we'll move on to see components of code pipeline. These are very important things which you'll be seeing in the lab session as well today. Three things: stage, action, and transition. Okay, what is a stage? This pipeline, the pipeline basically, it can contain multiple stages. If you're in an organization, you can have multiple stages such as source, build, test, staging, and production. And here, each stage consists of a series of actions which can specify what must be done on the artifact. And each stage can perform only one revision of the source code at a time. We will see how that happens with an example. All of the artifacts are stored in S3 bucket, not the build artifact which is produced from code build. Here, when we say different stages, while transitioning from one stage to another, the artifacts are stored in S3 bucket. I'll show you where it gets stored. And the transition is an action which is performed when one stage is moved to the next stage in the pipeline. It is represented by just an arrow mark in your original code pipeline. Okay, and these actions, what we call, can be either parallel or it can be serial or a combination of both. You'll understand this better when you see the example. So what are the actions that we have in code pipeline? Right? So here is the code pipeline actions in detail to see what all we can do as part of code pipeline and what third-party tools integrations are supported. These are at high level: approval, source, build, test, deploy, and invoke. At present, we have only manual approval type. And you can get the source from your build, source for your build from Amazon S3, AWS Code Commit, and GitHub. And build configuration from your existing Jenkins or AWS Code Build or Solinus CI. So for testing, it supports integration with several third-party tools and also some of the AWS services itself. And for deployment, it supports 5 kinds of configurations. One is your ECS, CloudFormation, Code Deploy, Elastic Beanstalk, and OpsWorks. In today's 3 workflows that we're going to see, we'll be seeing CloudFormation, Code Deploy. Okay, and we can also invoke Lambda function. This also we'll be looking at it. So these are the actions. So a quick look at the pricing. So if you have an AWS free trial account, you can get started with Code Commit for free, and your account gets 5 active users per month free, after which you can pay $1 per year additional active user per month. So build, you pay only for by build minute. You can create a code build project and keep it as is. You can use this rarely. It is not charged. And code deploy, there is no additional charge for deploying to EC2 instances. If you're going to try it, if you're going to configure with on-premise instances, it is dollar at a very lesser price. And a code pipeline, you pay only for what you use the services as part of build or code commit or the other stuff, or storing the artifacts, not for the code pipeline as such. And the pipeline is not charged for first 30 days. If you're going to try it out, what I would generally do is create it, keep it for 23 days, 25 days, test it. And when you're trying to do some experimentation, you wouldn't need it more than a couple of weeks. You can delete it without getting built. Okay, so it's a quick look at it. For details, you can refer the documentation. Just wanted to let you know, if you want to try AWS CI/CD using the Amazon tools, AWS services, so you'll not be built much. You can feel free to try it out on your own. It's a very good exercise. Okay, now if you have any questions, I can take them on the services that we have seen so far before we move on to the central theme of today's talk. I don't see any question yet. General questions which I've had in previous session is when we're using AWS code commit, can I move my existing source control system codes into code commit? Yes, that is very much possible. One is if you're already working on Git, moving to code commit is quick. I mean, it's a few simple steps. You just mirror it and then clone the code commit repository and put your local code, or you're getting it from other Git server directly to the code commit. That is one thing. And if you have to migrate from any other source control software like TFS, all that, so you'll have to first convert it into Git and then move it to this one. That is one thing which people ask quite often. So I'll tell you.
So from Perforce to Git is what you mean?
Yeah. In case if you wanted to migrate for any other source control tool for the matter, first it has to be converted into Git. And then to Git to code commit, it's straightforward and the steps are very simple, relatively few steps, which is already given in the documentation. I think we're good, as I don't see any questions. So let me move on. In this workflow, what we're going to talk about, if you have any questions, feel free to stop me, not a problem. So now, having seen the overview, let's move on to the central theme of today's talk. We'll be having closer look at three most important streams where AWS CI/CD is essential, and constructed three workflows around it, namely web application deployment, infrastructure rollout coupled with web application deployment, and serverless application deployment. First, we will see web application deployment workflow. So in this network diagram, Java web application is developed, that is pre-developed, and it is committed to a code commit repository. So it is available in the code commit repository. And also we have EC2 instances, which is already created. Okay, the code pipeline is not creating EC2 instance in this example. Why I'm specifically saying it is not creating, we'll see. So, okay, our code pipeline consists of three stages. We saw the code pipeline components as stage, actions, and transitions. The transitions are represented by the arrow. It has a 3-stage, and in each of these 3 stages, I have only one action configured here. Okay, so the first one is code commit. That is, you call, if you wanted to relate to the software release cycle terms, you will say this one is source, build, and deploy. I have only 3 stages here. So here I pull the source code from AWS code commit, which already has the pre-developed sample Java application, and then it pass it on to AWS code build. In AWS code build, we have 2 things. One action is to run your unit test, and the other action is to build and store it in the S3 bucket. Okay, so the artifact is stored in S3 now. Next, once it transitions to code deploy, in this stage, code deploy configuration pulls the artifact from the S3 bucket, builds, and then deploys to the existing EC2 instances. The EC2 instances which you have created might have a specific tag to group them as a deployment group, and that is already configured with your code deploy project. So with that tag name and the code deploy configuration, the AWS code deploy takes care of deploying your application changes to the EC2 instance. This forms your code pipeline. And once this is deployed, I'm assuming this to be a web tier. I've placed it in a public subnet, and you take the IP address of the instance or the endpoint and directly placed it on the web browser to view that the changes whatever you put is available here. That is very quick to see. Okay, this is one of our workflow. I'm going to show a demo of creating this pipeline later in the today's session. So this is the screenshot of the actual code pipeline from AWS console. We have 3 stages, as I said: source, build, and the staging. Why I meant staging is deploying to the staging environment. So the source from code commit, it has pulled the revision. This is nothing but it displays the comment. Yeah, the commit comment, whatever you mentioned, will get listed here. And in the build, this source, whatever is pulled from the code commit, is passed on here. It is built and it is passed on, that is, it is placed in the S3 bucket, and as part of the deployment is pulled and deployed. You see that it has succeeded 2 days ago, and there's no failure, everything went good. This deployment was smooth. So we will also see in case of failure, how do you debug later. And once it is done, I went to the IP address. I picked up the IP address of the EC2 instance, public IP address, and placed it in the browser so that I can see what was the content of my web application, what I attempted to deploy.
Hi, Bhuvna, there is one question in the chat window.
Okay.
The final deployment is always in an AWS EC2 environment. So that's a question.
Final deployment need not be always into an EC2 instances, right? As I've told you, the deployment, the code deploy as such supports the deployment to 2 kinds of configurations. One is either EC2 instances or on-premise instances. The other one, you want to deploy Lambda functions. So it supports all of this, right? So in the next workflow, we will see deploying to EC2 instance as well as creating that EC2 instances using infrastructure as a code. Okay, we're going to see that. So it can, in this example, I'll go back one more step to show you. See the deployment, it supports ECS, CloudFormation, Code Deploy, Elastic Beanstalk, or OpsWorks, right? So the deploy can support all this as part of code pipeline. And when we go to AWS code deploy, that supports EC2, on-premise, or Lambda. If you go to Elastic Beanstalk, the whole bunch of application can be deployed. You can also use OpsStacks. So there is no restriction that you have to deploy only to EC2 instance, right? So all these are supported. Hope this answered your question. Okay, next we'll move on to the infrastructure rollouts. So in this example, we will see how do we create an EC2 instance using infrastructure as a code, and then deploying our web application onto that EC2 instance that we just create. Okay, so we assume there are two teams. One is your development team working on a Java application, and your DevOps team working on infrastructure as a code. Basically, they're trying to create a set of CloudFormation templates which will be used to spin up your EC2 instances. So these two teams have their own two different repositories for segregations of duties, and keep their code changes different. Basically, most of the time we may not want to combine infrastructure change and application changes, because infrastructure change may not be that frequent and differs from company to company, and once it's stable. So we are maintaining in two different repositories, and our code pipeline here as well, it has 3 stages. Okay, and in this 3 stage, we have the first stage is source, pulling the source code from code commit. So I have 2 repos, as I said, and we saw that the action will pull source code from only one revision. So I have to add 2 actions here. One is to get the source code from Java repo, and the other one is from getting the source code for your CloudFormation template here. And this CloudFormation template may not have any action in the build stage, so I'm just moving on. In case of Java application, it goes to the code build, where I compile it, create an artifact, and store it onto S3. And from S3, this is picked up, and then as part of code deploy, we do 2 things. Here we have 2 actions, okay, as part of code deploy. First one, same code deploy action, it invokes the CloudFormation template to create the EC2 instance. So once that EC2 instance is created, we will run the another action, second action of the code deploy, which is sequential here. So that will deploy the Java web application onto the EC2 instance. In this case, EC2 instances are not pre-created. You can configure to create 1 or more instances. Here I am creating only 1 EC2 instances and moving ahead. Similarly, after this deployment, you can go ahead and see the IP address to view your index page content to ensure that deployment was successful. So this is our second workflow, where we first deploy infrastructure, right? The ultimate aim to move to Amazon Web Services is like we wanted to automate everything possible, right? What I'm showing you as an example for infrastructure as a code might be the tip of the iceberg. There is a lot more customization you can do, right from creating your VPC, your subnet, and creating security groups, and then creating EC2 instances. Everything can be done via infrastructure as a code. To reflect that, how it can be tagged in a pipeline, I use this as a simple example. Next, we will, here is the pipeline for the rollout, okay? So this is the web application deployment pipeline which we saw earlier, which had source, build, and deployment. Here, if you see, there are 2 actions. One to pull the Java application source, the other one to pull your infrastructure code. Okay, so here the first one is the commit comment for the first sourcing, and the second commit belongs to the CloudFormation template. So from here you will see whether your recent changes are picked up in this build or not. And the build, it builds only the first one, Java application I've configured, and after that the deploy section, here these 2 actions are sequential. First, it creates the CloudFormation, it runs the CloudFormation template to create the EC2 instance, and then deployment. So all went good, so it's all green. You may not get all greens at the first attempt. When you're trying for the first time, it's okay, but after several attempts, you would get it. But it's pretty straightforward. Once you try once, you will know the beauty of this code pipeline implementation. And Now, like we have seen these two, let's get started with the serverless application deployment, and we will cover few other interesting stuffs as well after that. So now we saw the deployment of web application that you've developed, and also about cloud perspective deployment via CloudFormation, which basically provisions your infrastructure. Now, coming back to serverless application, it has one or more Lambda functions, which are nothing but a compute service, and has triggering events like CloudWatch, S3, DynamoDB, etc., which can be associated with the Lambda function. So deploying of Lambda functions along with all of the associated resources as a bundle is termed as serverless deployments. I'm repeating. So deploying of a Lambda function or functions along with all of the associated resources as a bundle is termed as a serverless deployment. So with this little introduction, let's look into the serverless application deployment workflow here. So in this workflow, we have broken the monotony of having 3 stages. Now we are having 5 stages here. Here the development happens, we are creating the Lambda function that is required, and that is committed already to your code commit repository. So overall, in this workflow, a simple Lambda function using Python is sourced from code commit repository. It is configured to code build service for compiling and unit testing, and then based on the build spec.yaml, the code repo for Lambda. This build spec.yaml is placed in the root of your code repo for Lambda. The package is created and it is placed in S3. Okay, now your build step is complete. Now here are 2 different things, right? One is create stack and execute stack. What it does basically. So in your build spec.yaml file, especially for dealing with serverless application deployment, you have a very specific line called AWS CloudFormation package. So this, when specified in the build phase of build spec.yaml, it converts the SAM template into CloudFormation for create or replace stack. And what is a SAM template? It is basically an extension of CloudFormation template. You won't find any difference between the two. And the only difference that you see is the keyword AWS transform : serverless. This only makes difference. I will show you an example of AWS template. For now, we'll focus on these stages. So first, the stack is created and we are sending it for manual approval. So how this manual approval is configured is, it is nothing but an SNS notification configured to notify specified email address. For example, you're working on a Lambda function. I'll tell you the example which I've used here. Basically, you work most of the time, your development is working during IST hours. You use EC2 instances for your research or development purpose. And during your night time, these instances are idle. Okay, you create number of instances, play around, all that. And though we all agree on in principle that these instances should be brought down by end of your day, sometimes you might forget, or you thought, okay, it doesn't charge much, it's only per second charging, that's okay, fine, you leave it and go. But at the end of the day, cost saving is very important for everybody, right? So we have wanted to write a sample Lambda function which will be configured to trigger at 8 p.m. IST every day. Okay, somebody come at 9:30 and work till 7 or max 8 o'clock, we assume, right? So this Lambda function is configured to trigger at 8 p.m. IST every night to see the running instances, EC2 instances, with a specific tag. Probably you would give a development tag or something, or a testing tag, and bring them all that, shut them down. Okay, and the next day morning when the user come back, your developer come back, if they see their instances shut down, it will just take seconds to 1 or 2 minutes to bring their environment or your instances back and start working on it, right? This will save a lot of money for you. So this sample is about that. So first step is you create the stack. Here the Lambda function is not yet ready. So once this is done, you wanted to get it approved or reviewed by a manager. So you configured the SNS notification. And when it reaches this stage, automatically an email is sent to you, the manager, to the configured email ID. So there will be a link provided where the manager, he or she, can choose to approve or decline. So once it is approved, this green check comes to your that manual approval stage, and the execute stack is run and the Lambda function is created. So here the Lambda function executes the, when you execute the Lambda function, it scouts for the running EC2 instances, shuts them down, and put an entry in the CloudWatch logs, so that anybody who's interested, oh, what happened to my EC2 instances, first thing they would do is they'll go and check the CloudWatch logs. Okay, this is part of your schedule, cost saving schedule. The instances have been brought down, they can bring it up next day and use it. So this is the workflow with the 5 stages with a manual approval configured. Okay, there's no deployment to EC2 instances happening here. So EC2 instances, we can assume it was created in the previous workflow, right? So this is one of the workflow here. And this is the 5 stages, a screen print from the AWS console. You pull the source code for the Lambda function and you build it. This is where it converts the SAM template into the CloudFormation template, and it moves on to the staging. And here approval. Okay, this has sent a notification to my manager. He has not approved for past 21 minutes. Okay, if you're really keen to get this pipeline move quickly, just call him up, ask him to approve. Once it is approved, this will automatically turn green and it will move forward. So see here, no executions yet, right? So the next one, this is another screen where my manager have approved 3 minutes ago. I'm all set, and it has created the Lambda function. It's all done. So all green here. So now we saw 3 different workflows. Now we are going to see the template files. So what these template files, what we will be talking now, are basically the heart and soul of your AWS code build, AWS code deploy, and your SAM template. Okay. First, we will see the build spec.yaml file. So YAML stands for basically YAML. It's yet another markup language, and this file will hold collection of build commands and settings related to the build phase. Okay. This file should be placed either in the source of the root directory, or you can even choose to configure this file when you're creating the code build project for any code repo. Okay, the version number what is placed in the screenshot represents the build spec.yaml specification standard and not your project version or revision. Okay, and AWS recommends using 0.02. Okay, I have not used 0.02, but I believe we are supposed to use 0.02. So as per your requirement, you will have to add the comments against each of the build phases. You need not add comments in every section here, right? So here, if you see the install, pre-build, and build, I don't have anything. Okay, so what kind of commands can be added in each of this section? Here in install, it is recommended to use the commands that you would wanted to configure your build environment. And in pre-build, for example, if you wanted to install some npm modules, or if you wanted to sign into Amazon ECR, these kind of things, anything that you wanted to do before your build can be done here. And as part of build, I'm installing Maven. It is supposed to be done in this install phase. To show the difference, it doesn't make a big issue on having this configuration here, but ideally It has to be placed here. To show the difference, I put it in different places. And the build is where the actual build runs, and the post build. And here you can create a package, a zip file, tar.cz file, whatever you want to create, and you can push the images to your Docker container or the ECR. And you might even want to send build notification using SNS, or you want to put something manually to S3. All that can be done. You can name it anything that you do gently with your post build actions can all be done here. So you might wonder, an explicit artifact creation and upload despite the below artifact section. See, the above this command I had used when I wanted to configure and test code build separately, right? For the first time when I'm trying, I wanted to make sure my build gets uploaded. So I have put that here to see an explicit artifact gets created. And if I'm trying to configure a code deploy separately, all that I worry is I assume that an S3 bucket exists and artifact exists that I'll just pull and deploy it. So that's why this served the purpose. But ideally, when you're using with code pipeline, this should be sufficient. So these are the actions. As I've told you, the install, pre-build, build, post-build. In these area, you can put your commands, whatever you want to execute. These are system-defined actions. This indicates that you have submitted for code build, and it will provision the resources. That is, automatically creates a container image for your, prepares your build environment. Provisioning is all about preparing your build environment. And then it downloads the source code from the code commit or GitHub or S3 bucket, whatever you specify. These are the actions which we just saw. This is about uploading the artifact, finalizing, and we are done. Okay. So now we saw build spec.yaml. The next one is the central part of code deploy, app-spec.yaml. The screen print, what we see here is about the app-spec.yaml, which is used for web application deployment. This is a configuration file that specifies the files to be copied and the scripts to be executed. The app-spec file again uses YAML format, and you have to include it in the root directory of your revision. This file is used by the code deploy agent to do your deployment. And it has two sections. One is file section and hook section. So the file section specifies the source files in your revision to be copied to a temporary location. That is the destination. And the hooks section specifies the location of the scripts to run during each phase of the deployment. Okay, we will see what are the phases here. And the most important thing you have to notice, similar to build-spec.yaml, app-spec.yaml should also be placed in the root of your source code repo. Since this file is more to do with application level instructions and actions to be done, informations like OS, file source, and destination for each of the artifacts deployed will be mentioned in this file. Now you see the EC2 instances which I'm using for the deployment is Linux instance. So that's why OS I've mentioned. So you can use different hooks at application level, either before install, after install, all that. And these scripts may or may not be applicable to your application and differs based on your requirement. Hence, configure these actions that will suit your needs. Okay, so these are the different actions: application stop, download the bundle, before install, after install, what you do, and you start the application and you wanted to validate the service. All about traffic. The traffic related will come mostly for your serverless application, that is Lambda functions, or when you're using ELB. We'll see the two different workflows. The content of the hook section of the app-spec file varies depending on the compute platform for your deployment. We saw that two kinds of compute deployments, compute platforms are supported for deployment. One is Lambda deployment, other one is EC2 instances or on-premise instances. So the first workflow we are seeing, right? This is for hook script, how it can be positioned when you're doing Lambda deployment. Start, before allowed traffic, after allowed traffic, and end. So in before allowed traffic, you run the tasks which you wanted to run before the traffic is actually shifted to the newly deployed Lambda function. This one is when it is moved to the newly allowed function. Okay, so these are the events which we'll be using. And what are the hooks that we will be using in case of EC2 on-premise deployment is this. For example, if you're doing a web application deployment on an EC2 instances, first you would want to stop the application and then download the bundle. Download the bundle is all about downloading your artifact stored in S3 or GitHub onto the temporary location and then start your installation. So whatever you want to run before your installation, like you're extracting your artifact or decrypting the artifact, all that can be configured to run in before install. And install is where your code deploy agent actually copies your revision, application revision to the target location. And the important thing to note here is either in the download bundle or in this install section, you cannot configure your custom script. This is meant to be executed only by code deploy agents, so you won't put anything here. So once you've configured in your code deploy project where the artifact have to be fetched from, that's all, the job is done. You don't have to write anything here. You will not be allowed to write as well. So if you want to do some post-installation steps after your installation, like configuration and all that, you can do an after install. And then you will bring up your service as part of application start and you will validate, have some basic validations. You can put them here. And before block traffic is like when you're coming to the load balancer side, you can run some tasks on instances before they are deregistered from the load balancer. And in this block traffic, internet traffic is blocked from accessing instances that are currently serving traffic. So this event is reserved for AWS code deploy agent and cannot be used to run scripts. Okay, so and after block traffic is, you can run tasks on instances after they are deregistered from the load balancer. And the allowed traffic is similar to the above one. So these are the hook scripts with aspect.yaml. And now this template.yaml file. As buildspec.yaml is for code build and aspect.yaml is for code deploy. This is for your serverless application build basically. Okay, the template.yaml file is hard for that. Okay, we will see what it is. Here, AWS serverless application model, in short, you would say AWS SAM is an extension of AWS CloudFormation template language that lets you define serverless applications at a higher level. This SAM template is used, or it can be used to define for Lambda deployments. If you see this transform colon AWS serverless, this is the only difference from your traditional CloudFormation template and the application server deployment. As part of your build, the third workflow that we saw, the buildspec.yaml invokes this file, runs a command to convert this template file into a CloudFormation template, and that's how it's used. Okay. So now we saw the templates. So far, I've been showing all greens, right? In my pipeline, whatever we saw, 3 different workflows, all green. So everything goes good, we are happy. And what if something fails? Okay, so after something fails, we'll not be able to do anything. We should have done some logging enabled in first place. to identify the issues. So the first and foremost, we must have enabled build logs for CodeBuild to be captured either to CloudWatch custom log group or to S3. Okay, so then only you will be saved for debugging your build. Otherwise, you will not find anything on the log side. Where will you look into it for the issues? So these logs, once you configure, gather and retain the verbose level information for build and build stages and provides us extensive level of information to identify the root cause of the failure and fix it quickly. So if you see here, I have enabled CloudWatch logs. Okay, so not S3 log. So CloudWatch log for the viewing full log, the link is here. Since I've enabled the log, all these things are captured and I have a failure here where I've mentioned the S3 bucket name as incorrect. Okay, since I've mentioned the incorrect S3 bucket name, it has failed. So I went to the CloudWatch log. I can look into it for the issue. And also in the dashboard, AWS CodeBuild dashboard, you can go to the events to see the logs here. So now, although CodeBuild supports logs and developers can monitor the build progress from AWS Management Console, it can be difficult to track down issues that might specifically related to the CodeBuild environment. And these issues might be missing permissions on the AWS IAM role associated with the environment or any changes. So both of these issues makes debugging very, very difficult. Okay, so to make the matter worse, AWS CodeBuild isn't as fast as debugging issues locally. So it might slow down dev team if they have to wait 15 minutes to see a particular change fixed. Okay, so to avoid all these things, right? Local build support for AWS CodeBuild was launched, I think in May 2018, which came as a blessing in disguise, definitely. So how do you do the local build? You can get the CodeBuild Docker image file from the GitHub, build the CodeBuild image locally, set up the CodeBuild local agent and use the local agent to build your projects. See, these instructions are clearly defined in the documentation or the blog is available. So you follow the instructions, you can do the build locally. You don't have to wait and go and do it every time online, or you can save some cost with this as well. It's very quick. And by building an application on a local machine, you can test the integrity and concerns of a build spec file locally. And you can also test and build an application locally before you commit the source code. You can identify and fix errors quickly from your local development environment. So all these things are advantages of having a local build support from AWS CodeBuild. So that's about debugging your build. The next one is, in case of failures, we need to debug or analyze, right, why the deployment has failed and what went wrong. That's what we're going to see in debugging deployments. Okay, so we all know that AWS Code Deploy helps user to deploy the software to a fleet of Amazon EC2 instances or on-premise instances. Okay, and we learned that the Code Deploy agent is the one which drives the deployment on these instances, be it an EC2 or an on-premise instances. First, you have to make sure the Code Deploy agent is installed, up and running. Then only the deployment is possible. Okay, so the agent generates 3 logs. The first one is agent log. And we have deployment log and updater log. We'll see the agent log first. Agent log contains information about the agent's health and overall deployment status. It is available in this where log AWS Code Deploy agent path here. Here is the, first few lines of this Code Deploy agent log in one of the deployment. And deployment log. This contains your standard output or standard error and information specific to user-defined scripts that run during the deployment. For example, in case of our web application deployment, we need Tomcat and Java to be up and running on this system, right? For our web application to be deployed. So we run a bunch of script to do that pre-installation configurations. So anything related to that can be captured in the deployment logs. That is whatever the script that execute, right? And the next one is update a log, and this is very specific to Linux agents only. It contains agent updated status. May not have much information for us for debugging. Good to be known. And it can be cumbersome to sign into the EC2 instance to view these logs, particularly when there are a large number of instances, right? Okay, so if you have a production environment running, which will have like hundreds of servers, you'll not be able to log into all instances first place. And it is not a best practice to give SSH or RDP access for people to log into those systems. That is another thing. So for all these things, it's good to install and configure CloudWatch Agent. CloudWatch Agent is an agent which will fetch the log files that you configure to capture to the CloudWatch logs. So it's good to install CloudWatch agents on the EC2 instances, and the logs will be captured into the CloudWatch agent, which data can be viewed for detailed analysis. That's how you can debug your deployments. So now, how do you roll back deployment? If a deployment action fails for some reason, in an ideal world, we roll back to the previous version of the application that failed, right? That's what we say rolling back. In AWS world, the rollback is nothing but redeployment. So for every deployment, logs and artifacts are retained on the EC2 and on-premise instances. And based on the rollback configuration settings in your co-deploy project, the rollback, that is actual redeployment, takes place efficiently. If you see here, here is an option which you would have turned on in your co-deploy project configuration. So based on this rollback happens. So you can also specify enabling automatic rollbacks. These are basically options that you have while you are configuring your AWS co-deploy project. And also you can create custom deployment configuration which helps in defining rollback based on the number of healthy instances or percentage of successful deployments. And this custom defined deployment configuration can be chosen while defining the co-deploy project or a stage. So the next one is, how do you have a generic pipeline setup? All we have been talking about deploying to a staging environment or production environment. How can I have a generic setup, a code pipeline, which I can use for any environment? That I'm showing it via an example here using a CloudFormation template. Okay, so we have used earlier CloudFormation template to create EC2 instance, right? I'm using the same example here. So in order to make a generic pipeline for test, pre-prod and prod, provision your environments by defining different environment group in your CloudFormation templates like dev, test, staging, etc. If you could recollect the tagging I was mentioning for EC2 instances relating to web tier, it can have a tag, app tier can have a tag, and similarly another suite of tiers in your web application have a different tags. So you create an independent environment specific configuration file and map these configuration.json files in your stages that you create in your code pipeline against each environment. That is, for example, the test stage of code pipeline will have test configuration.json, and the staging stage of code pipeline can have staging configuration.json and likewise. So this JSON file sends the input to your CloudFormation template, which will tell whether you want to deploy onto your test environment, your production environment, or pre-production environment. So let's have a closer look at the CloudFormation template here. So CloudFormation template is a declaration of AWS resources that make up for a stack. A stack is nothing but a collection of AWS resources that you can manage as a single unit. In other words, you can create, update, or delete a collection of resources by updating or deleting stacks. That these jargons might be a little confusing, but in a simpler terms, the CloudFormation templates has all these things. Okay, it can be represented as your JSON file, or it can follow YAML standard. Your CloudFormation template can be represented in two ways, or it follow two format, which would comply with JavaScript object notation, which is JSON or YAML standard. Okay, this includes version and a description in the beginning, which we saw here. See, version and description will be in the beginning, and then the parameters, mappings, resources, and outputs. These are the different section of your CloudFormation template. And you declare parameters in the template's parameter object. A parameter contains a list of attributes that define its value and constraints against its value. The only required attribute is type, which can be string, number, or AWS specific type. Right? For example, if you wanted to pass environment name as a parameter, you can define it as a string and then pass the value. Okay, and the mappings, assume an example. If you wanted to specify a specific AMI, okay, mission ID, or you call it as an AMI, as an parameter. This AMI differs from region to region, right? If you have configured and created an AMI template and kept it in one, probably Mumbai region, you might have replicated to US East, West, or Singapore region for different reasons. So here in this mapping section, you can mention the region and the corresponding AMI to be used. And in the resource section, you define what resource you wanted to create and configure. The output section can have things like written the public IP address of the instance that you create, so it will be used later. So this forms the template, and this template, when you pass the parameter values, you would create a stack. Stack is nothing but a collection of resources. If you are having the CloudFormation template to create an EC2 instance, the stack will constitute a single or multiple EC2 instances based on your configuration. So how do you make it a generic pipeline? By passing the parameters. By having different parameters, you can achieve the generic pipeline here. So now we saw the CloudFormation template, the different workflows, right? So how do you gauge the DevOps? We saw AWS CI/CD. By implementing this code pipeline on that, we'll have to first evaluate and see what is the advantage in doing this. So how do you gauge it? Basically is to strongly come out with an efficiency of CI/CD implemented, we will have to assess them with few pointers like deployments in comparison to earlier rollouts should have definitely increased. Otherwise, there's no point in moving to CI/CD using AWS, of course. And the time to market should be reduced. So increased feature releases and reduced time to market. So defects raised or being captured at pre-prod and prod should be less in comparison to the testing phase, as we have the continuous integration implemented successfully now as using AWS code pipeline. And incidents in pre-prod or prod should have ideally come down drastically, because most of the things are taken care as part of CI/CD cycle, and it was acted upon quickly. We should ideally be having highly available, elastic, and scalable infrastructure from now on. You have a highly scalable build environment. You don't have to purchase them and keep them ready. They are up and running all the time. You don't have to take care unless you wanted to bring down them. So all these are your metrics that you would be interested in gauging. So this is about the things I wanted to cover. The next one is, we will move away from the slide deck. We are done with the slide deck, and there are two important things which we are going to see now. One is the mind map about CI/CD workflow to see the devil in the details, and the next one is demo of AWS code pipeline creation. Okay, so we'll see the first one. I'll switch to the mind map. Oh, I've shared my desktop, so you should be able to see it. In case if you don't see it, let me know, alert me. Okay, so this is the mind map I've created before I actually implemented 3 different workflows in my personal AWS account. I just want to tell you, those workflows, whichever I've showed you, is not a network diagram just prepared on a Lucid chart for the demo purpose. Actually, they were all designed using this XMind as a flow, implemented and tested in the account, and then output of it. So we will see the 5 things. I have 3 mind maps. I'm going to talk only about the first mind map, that is the workflow for creating web application deployment. We'll be seeing right from how the prerequisites were configured, code commits, code build, code deploy, and code pipeline, all the configurations. Okay, first one is prerequisite. On my personal account, I use root user to log into console, and as a best practice, I'm not supposed to use root user to perform any other operations. So first and foremost, what I did is, I will create a user which I'll use only for this CI/CD pipeline implementation. So I wanted to create a code deploy user. Even before that, it is another best practice that we shouldn't be attaching policies directly to the user, right? It's always good to have a separate group in case if I wanted to create a bunch of other users who want to have similar roles and permissions. Okay, so that's why first I created code deploy group and attached these policies. Okay, AWS code commit, I'm giving full access. So these are all, and this is not best practice, there are slight deviations. Since it's my own repository, sample repository, I'm granting full access. If you want to create another user who want to have read-only access, then you feel free to do so. So I'm using CloudWatch because I wanted to log the build issues in the CloudWatch, custom CloudWatch log group. So this access, code deploy full access, so IAM read-only permissions, and code pipeline full access, code build. So for all these services which I'm going to use, code commit, code build, code deploy, and code pipeline, I've given enough access. And over and above this, there are a few things required. So IAM create role and policies. As part of code build creation or code deploy creation, if you do not have the roles or policies created, you will specify the AWS itself to create a policy for you. So when you choose that configuration, these policies are required. That's why these additional policies are added here. And then I'm creating a user and attaching to the group. Okay, I make sure I download the credential CSV file and copy the signed URL so that I can log in as this particular user into the AWS console and start working on it. And I also made sure to generate Git credentials. This is very important for me to log into code commit. Okay, so now I'm logging in as a code deploy user in the console. and I need a CloudWatch log group and then a Bitbucket. S3 bucket. So I'm creating CloudWatch log group and S3 bucket. So with this, my prerequisite setup is done. And then I'll move on to code commit. In code commit, from console, I create a repo called code commit demo. And how do I put the Java code which was developed locally, right? So you clone the Git repo. When you create the repo, you will see the command there to clone the repo. Use that to clone it on your command line and download the sample application. Okay, so why I'm saying download the sample application is if anybody is curious to experiment this implementation on your own, I have an extensive blog on this, and also the sample application used for Java application or CloudFormation or Lambda are all uploaded into GitHub repository, and the links are available in the blog. So that's why I meant download the sample application from GitHub and use GitHub add dot, right? It will add everything. So now you push it. So your code is available in your Git repo under the name code commit underscore demo. So it is there. Now the next is configuring the code build. Keep it very simple. In code build, all that we want to say is what do I want to build and how should I build, where should I store, where should I log. It's all here. It's very simple. You give the repo name, and once you give the repo name, automatically it will load the branches available. You select the branch. I was working only on master branch, that's why I put master. But in the real world, you might have multiple branches. And the environment, right? So I am choosing Ubuntu as the operating system and Java as the platform, and going ahead with the JDK 8. And I'm mentioning to use the buildspec.yaml, which I placed it in my source code root directory. Okay, remember I told you there are two ways and you can pass. You place it in the root directory or pass it offline. So once I have specified these information, I am mentioning the code deploy log group, which I've created earlier in the prerequisite section. And you just specify a stream name. This you can give for your easy reference when you go and look into the CloudWatch logs. And you configure to create code build service role automatically. This is why we gave the fine-grained permissions of IAM create roles. The next one is code deploy project configuration. See here, you might be familiar with the details of creating EC2 instance. So let me not talk about this. So these things have the information about that. For EC2 instances, what security group it should have. If you remember, for debugging, you need SSH access, and to browse through the URL, you need HTTP. So I'm leaving it open to the world. So it's not the recommended way, though. You might want to restrict to a specific subnet, also do it. Let me not get into the detail of IAM and creating EC2 instance. So we are going with an assumption that EC2 instance is created, okay? And then code deploy, creating a code deploy project. So here we are choosing EC2 or on-premise. I wanted to deploy onto EC2 instance. I give the deployment group name. So here it's a Java web deployment group, and I'm going ahead with in-place deployment. And I'll mention the tag name for the EC2 instances, which I'll be using. And I'm going to deploy, even if I'm having 10 instances, I want to deploy only one at a time, okay, to see how it goes. And this is the service role. If you have already created, use that. Otherwise, you mentioned to create a service role. The project configuration will create one for you. Now the code deploy project is created. We wanted to glue them all together in the code pipeline. So in code pipeline, it is pretty straightforward. You give a name to it and then specify the code commit repository from where you want to pull the source code and what code build project that you've configured here, that details, and what deployment group that you should use, which you've already configured in the previous step. This service route, which I've already created, I'll be using that code pipeline service. So this section we are going to see now. Doing all these things in a live demo, it will take longer time. Let's see the last part. I have the code build and code deploy project already created for you. So I am into AWS Management Console. I'll just show quickly the code commit repository. So here in AWS Console, under developer tools, we have AWS Code Commit, Code Build, Code Deploy, and Code Pipeline. These are the tools we have been talking in all through this session. And this is the dashboard of AWS Code Commit. And I have two repos here. One is Code Commit Demo and Code Commit Infra. Code Commit Demo is the repo which I'm going to use for this session. As we have been talking, the app.spec.yaml and build.spec.yaml are placed at the root of this directory. This is the actual source code under SRC folder, and this scripts folder have the files that I'll be running during my deployment to install the dependencies like Tomcat and Java, either to start and stop the applications. All these things will be available in the script folder. So now, if we go to the visualizer, here is the commits. I'm sorry, I've been working only on the master branch. So it's for this sample application. So you see only the commits to this particular application. So here's a compare tool if I wanted to see the differences. Okay, now we'll move on to the code deploy. I've already created the code deploy application. Okay, before that, I need to start the instances. Okay, I have one EC2 instances which I have already created. Now I'm going to start the instances so that as part of my code pipeline, the deployment will happen. So while this instance starts, here is the code deploy application. And also if we wanted to see the code build project, I'm opening that in another window. This is the code build project that we have created earlier. I have done a bunch of builds in the past. So the build details is source, it is configured to code commit demo, and it's using Linux build environment. I'm using with the basic compute type. There are 3 types of compute type available. For my simple application, the basic one was suffice. So I went for that. I didn't configure any specific environment variables for this. Artifacts are stored in demo AWS CI/CD S3 bucket. Okay. So I've already created this bucket, configured, everything is in place now. So instead of starting the build here independently, now I'm going to create a code pipeline. Okay. So I do not have any pipeline here. For the first time, if you go to the dashboard and open AWS code pipeline, this is how you will see the instructions to get started, because I do not have pipeline yet. Now I'm going to create a pipeline. Code pipeline, and that's the name I'm giving. I'm going to use the existing service role because I already have one AWS code pipeline service. So I was mentioning about from one stage to the other, the artifacts are passed internally through S3 bucket, right? You can let it use the default location, or you can specify to use custom S3 bucket. I'm going with the default location. This is not the place where your actual build artifact is stored. This S3 bucket, what we saw, is internal to code pipeline only. Don't get confused between the S3 bucket that we will be using to store our artifact and the S3 bucket which the AWS code pipeline uses internally to store its own artifacts. I'll show that. Okay, and the source provider, I'm going to use code commit. So I'm going to use Java application. I put it in this repository. Now I'm going to choose the master branch where I have a working code. The change detection, I'm going with the Amazon CloudWatch events, which is the recommended one, because it's not good to poll and see in a specified interval. And the build provider, AWS code build. Once you choose that, it will list the available projects. I have only one project, Java web build. I'm going to choose that. And then next. Here you have to configure the deploy. We are done with the adding source, build, and now deploy section. So deploy, we are going to use AWS code deploy to deploy to the running EC2 instance. So I have already created the application named Java application, and in this I'm having only one deployment group as Java web group, and I'm going to move on to the next screen. So here it will ask you to review your configuration. You have chosen the artifact default location for pipeline using your predefined service role name, code commit repository details are mentioned here, build project, deploy. All looks good. I'm going to create the pipeline. As soon as you create the pipeline with the latest commit changes available here, see, congratulations, the pipeline named code pipeline underscore demo has been created. I'm going to close that. So it has started fetching the source already. So it's in progress. It'll just take very little time. If you want to disable the transition, you can do so, but now I wanted to show you the full flow, so I'm not disturbing it. So while this runs, see, these things haven't run yet, right? So while these things run, independently, I wanted to edit this and show you about the artifact. Now this is done. The build is happening. So with the interest of time, let me edit this and show you what does the artifact storage space or S3 bucket means. So in this edit, I have three stages, right? Source, build, and deploy. To this section, if I want to add another action, I can do so either before or after or in parallel. Now I'm not going to do any additional actions. I want to show you how the output of source stage is passed as an input to the next build stage. Okay, so here is an internal name. It is already given, a source artifact. Using this name, it will store in the S3 bucket and it will pass on to the next stage. Okay, so we will see now, edit the stage. You will be able to see from the previous stage, the source artifact is passed as an input here, and here you would generate the build artifact, store it in S3 as well, and this in turn again passed it to the next stage, that is deploy stage. Okay, this is how the artifacts will be passed from one stage to another, and this is independent of what you store in S3. I'm again saying that, reiterating it. So I didn't make any changes, so I'm just canceling it. Okay, discard the changes because I didn't make anything there. So now back to the pipeline. The build is done. The artifact should have been stored in the bucket. Now the deployment is in progress. Okay, so now let me go back to the S3 bucket to show you where the artifacts are stored. This is our S3 bucket where I intended to store the output of the build, Java web. Okay, now we were talking about one other bucket, S3 bucket, where in code pipeline, the artifacts are passed from one stage to another, right? That is here, code pipeline. It starts with code pipeline and the region name and some internal representation. Okay, I go there. So this is a project name, code pipeline project name, what I have given. Here you would see the build artifact and source artifact. So in these folders only, the content what get transferred from one stage to another is stored temporarily in these places. Okay. So one important thing that you have to note down here is when you create a code pipeline project and you mention to use a default, this folder gets created automatically. But an important thing to note is this doesn't get deleted when you delete the code pipeline project. In my case, my application is in KBs, 4.7 KB. It's nothing. Okay, whether I clean up this or not, it's not going to cost much. But in case of an enterprise applications build or deployment where your source code sizes in GBs and artifact size is also going to be in GBs, that's going to cost more. So it's good to have a periodic cleanup on those buckets and the prefixes as well. So now we'll move back to the code pipeline. The code deploy seems to be still happening. Let me go to the event and see where is it exactly. Now, I'm going to view the events. Everything looks like it's still pending. Okay. Okay, I think I started the EC2 instances, but I didn't start. That's the problem. Demo is supposed to always fail for the first time, right? Okay, so now only I'm starting the EC2 instance. It's in pending state. I'm sorry, it's not the intentional thing. So let's see whether the code pipeline automatically detects the instance and continue with the deployment. If not, I have to reinitiate it again. Let me give a minute here to see what's going to happen. EC2 instance is still, it's in running state. I'm set. So if you have any questions while this runs, you can start. Okay, it went through. I think it was a auto refresh issue. So our deployment have succeeded. Could see that. Now we'll go back to the EC2 instance. I'm going to copy the IP address, open another tab. Okay, so now the deployment is done. You might be wondering whether I've already pre-deployed and showing it, or also to see how the source detection happens automatically. I can go to the index page, make a quick commit just for the purpose of demo. Go to the index.jsp. I'm going to edit it. Okay, live demo to see the changes. I'm going to commit it. Okay, email is. No spam emails, please. Okay, so now I've committed the changes. Let's go back to code pipeline to see the build. It should actually detect the changes and start the build. The previous one was over a few minutes ago. let's see whether it automatically detects the changes and start. Let me give a minute for it to detect. If not, we will trigger. Ideally, when there is a commit, it should trigger automatically. If not, we can click on this release change and detect. I'm going to leave it to see what happens. Meanwhile, we are done with the demo, and this is what I wanted to show you. I'm just waiting for you to detect automatically, and the question and answer session starts here. We will come back to this. We will see this. Okay. So now, like with the interest of time, I'm going to trigger this release change. Okay. So I want this change to run so that we can see the quick change, whatever the commit we have made to the AWS code commit repository, and then move on. So now the source is fetched. It is passed on to the build section. Since it's a simple application, it shouldn't take much time. While the build is happening, we'll go to the build log. Since we have enabled the CloudWatch logs, right? I'll show you how the logs gets listed. You see this detailed logs just because we have enabled the CloudWatch logs. If we have not enabled, you will not get all these informations here. So it will be easier for you to debug. I'm going back to the pipeline demo. So the build is done, deployment is in progress. We will know whether the deployment has succeeded or not if we're going to refresh this and see. The new line is added. Yes, success. So live demo to see the changes. This is the text we added to the index.jsp as part of our new commit. So it has come immediately. So this is how the AWS code pipeline can help you integrate right from your source to deploy and get the changes quickly to whatever the environment that you wanted to take it. Okay, this is the point I wanted to make it here.
So that's it. This brings us to the end of this session. We have successfully understood how developer services work on top of AWS. Then we've gone ahead and understood what are different AWS DevOps services, taken a look at certain use cases, and have finished this session off by understanding how AWS code pipeline works. Thank you.